Number 61. Even though CaOH2 is an inexpensive base, its limited solubility restricts its use. What is the pH of a saturated solution of calcium hydroxide, which is CaOH2? Okay, so they're talking about solubility with a specific compound, right? And they said that it's saturated. So that means that it's not unsaturated, it's not a supersaturated solution. So that means that we're right at the cusp, or like the brim, before we start forming a precipitate or a solid. We want to know what is that pH right before we make a precipitate. Well, in order to do this problem, I had to go in the back of the textbook to find out the solubility product of calcium hydroxide. So solubility product, the KSP of CaOH2 is 1.3 times 10 to the negative 6th. Now remember, with any KSP, there has to be a balanced equation. So I'm just going to write that out. You always start with the solid, and in this case, it's the calcium hydroxide. So CaOH2, that's the solid. This will dissociate, so double arrow, equilibrium, into its two ions. In this case, remember, hydroxide, OH, never breaks up. So it has to be between the calcium and the hydroxide. There's a couple of ways to find out the charges of each of them. The easiest way is probably just, memorizing your trends on the periodic table. Calcium is in group 2, so they're always a +2 charge. And hydroxide, we've seen it time and time again throughout this whole journey, hydroxide is always a -1 charge. Since they are charges, that means that they are aqueous. And just make sure that your equation is balanced. You do have 2 hydroxides, so I do have to put a 2 in front of the OH. Okay. And now we have our balanced equation. Now they told me that it's saturated, which means that there's no common ions, right? So there's no other ionic compounds that have calcium or hydroxide affecting, our values here. So from there, we can just write our specific KSP equation, right? The general one is this. It's just KSP equals the concentration of the products raised to the coefficients. So let's do ours. KSP would equal the concentration of the two products, so the calcium 2+, times the hydroxide, OH-, and just make sure that you raise them to their coefficients. I do see that I have a 2 in front of the OH, which means that I do have to raise that hydroxide concentration to the second. Well, we do know that the KSP was 1.3 times 10 to the negative 6th, but I don't know the concentrations for calcium and hydroxide. So I'm just going to write variables, right? So let's start off with calcium. I don't know what the equilibrium concentration of calcium is. I'm just going to put an X. And just know that it should always follow the coefficients. So since there was 1 calcium, this technically should be a 1x, but 1 times x is x, so we could leave it at that. But for the hydroxide, if we label it as an X, that 2 has to come with it because it's a 1-to-2 mole ratio. So whatever the calcium value is, hydroxide has to be double. Now we know that the calcium is going to be X and the hydroxide is going to be 2x. Okie dokie. So 1.3 times 10 to the negative 6th equals, we have our two things. So we have x times 2x squared. Remember, 2x squared is just saying that you have two 2x's and they're being multiplied by each other. So 2 times 2 is 4. I have 2 x's, so that would be 4x squared. So I'm just going to erase this and say, okay, this is the same as 4x squared. I'm grouping together one more x value. So it would be 1.3 times 10 to the negative 3rd equals 4x cubed. We want to solve for x, so I divide on both sides by 4. And now I will move over here. X cubed equals 1.3 times 10 to the negative 6 divided by 4. I get 3.25 times 10 to the negative 7th. Now I just need to undo the cubing, so I could do the cube root on both sides. Just know that the cube root is the same thing as raising this to the inverse value. So since this is 3 over 1, I can just raise this to the 1/3. And then I'll do the same on this side. So raise to the 1/3 or cube root it. Okay, so this goes bye-bye. And now I just have x equals, and whatever the cube root of that number is. So this raised to the 1/3. Oopsie. Oh, boys. Oh, boy. Okay. Syntax error. How dare they? Let me see. Okay, there we go. So 6.875 times 10 to the -3rd, and that's similarity. Now, keep in mind, we want to find out the pH. So we say to ourselves, okay, from this x value, right, this belongs to the 2 ions, calcium or hydroxide. Which one of these will lead me to a pH? This is last chapter. This is the OH minus concentration. Remember, from last chapter, I can go from an OH minus to a POH, and from there I could finally find out my pH value. But we did say that the hydroxide ion concentration was 2x. So I have to plug in the x value and times it by 2. So the x was 6.875 times 10 to the -3rd. So I just have to times that by 2. So 6.875 times 10 to the -3rd times 2. I get 0.01375. And that's molarity. Now I know what my hydroxide concentration is. So let's now perform the steps. I'm going to go from an OH minus to a POH. What is that formula? That's why I wrote these down here, right? And let's see, maybe I will put this up here now. So POH equals the negative log of the OH. So technically, if I wanted to find out my POH, I would just do the negative log of the OH minus concentration, which is 0.01375. It's the number that we just found out. So let's see what we get. POH equals negative log of that number, 1.862, I guess we'll say 1.86. So if I want to find the pH, which is now where we're at here, if I want to solve for this, all I would have to do is just minus the POH on both sides. So if I just bring the POH over with the minus sign, look at that. And I say to myself, okay, pH has to be equal to 14 minus the POH. pH is just 14 minus 1.86, right? It's the answer to what we had before. So finally, we get that answer. And pH is 14 minus 1.86. I get a whopping 12.14. And this answer checks out because this pH value is basic, right? Anything above 7 is basic. And calcium hydroxide, that's one of your 6 strong bases. So we should have a basic pH. So it kind of checks out. I really hope this helped you out. Let me know in the comments. Thank you so much for viewing the video. Stay tuned for more. We got more coming your way. We have physics videos and math videos on the channel, so go check it out. I look forward to helping you in future lessons, and I will talk to you then. Bye-bye.